Okay, welcome back. So this is the next day of notes, Unit 11, Day 2. Let me set this down a bit. Here we go. So I am on the note packet on page 7 here. And we're doing a little bit more on the exponents. It doesn't initially look like this. So it's like we're just doing division here. But the idea of this is saying, just remembering what 2 divided by 2 is. And of course that comes out, you know, they cancel each other out. But we always have to have something. We can't just say cancel and there's nothing left. This is also 2 divided by 2, which is the number 1. And again, same thing here, 147 divided by 147. Doesn't matter what the number is, top or bottom is exactly the same. And when you start throwing variables into the mix, there's m to the 5 on top, exactly the same on the bottom. These cancel out to be 1. Now, it gets modified on the end here. We have 3x to the third and then over x to the third. Now, these two are working together, and the 3 on the in the front is just going to sit there. So it doesn't have anything to do. So it's going to say, sit there and say, well, this is 3, and then this over this, when they divide out, is 1. So just 3. So when we're working with this, kind of the rule is when the same thing is on top and bottom of a fraction, we cancel them to equal 1. Now this comes out to be used in exponents, and initially when we look at this, we don't have any exponents on the first and the second. And when that happens, that means a 0. But I'm going to pull number 3 here. We use m to the 5th over m to the 5th. The 5s as the exponents are a little bit easier to say. Sorry, to see. So when we are working with this, we say this is m, because it's the same variable top and bottom. And we always do the top exponent minus the bottom exponent. So this, of course, simplifies to a 0. And anytime a base, this is what the m is, the base, so anything that carries an exponent is referred to as a base. The base has an exponent or power of 0. That whole part changes to the number 1. So anytime we work with a 0 as the exponent or the power, that part changes to the number 1. Now this is kind of a couple different versions of these, and it's very nice when you have a whole bunch of stuff to a 0 power. But not everything is canceled out when the 0 power. We have to be very careful about this. All right, so this is a variable to an exponent. So anything to a 0 power means they canceled out, so we just have 1. And that's the answer. X to the 0, that's the number of 1. Now when I have 2 things in here, they have the exponent of 0. This means 8 to the 0 and x to the 0. Okay, the 0 goes into both. Well, 8 to the 0 is a 1. X to the 0 is a 1. So we're ending up with 1 times 1, which is just, again, 1. Now, it would be very nice going straight forward. I'll be like, oh, this next one's going to be 1. The next one's going to be 1. There are parts of it when you see a 0 that are going to be 1. So this 4 is sitting here in front. It's still going to sit there. It doesn't get the 0 power because it's not in the parentheses with the to get the 0 like the other one was. So the 4 is sitting there. And now we get x to the, and I multiply those. Oh, 100 times 0 is 0. So this means I'm doing 4 times 1, which this time changes. So part of it changed to the number 1, but that wasn't the entire problem. I had to multiply it here with a 4, and 4 times 1 is 4 now. This last one, so I have x to the 4th, y to the 0, and z to the 5th. This part is what we're working on. X to the 4th sits there. It doesn't have anything to do. It can't combine with anybody. Times 1 in the middle times z to the 5th. All right, if I multiply them by 1, well, I can just simplify that, and I have 1x to the 4th times 1 times 1z to the 5th. So this is x to the 4th. This stays as x to the 4th and z to the 5th. You can write the 1 in front that we're multiplying if you want, but you don't have to. And this is just where we would finish. We'd be done there. We can't combine an x and a z. They stay separate. All right, the next thing we look at is what happens when we have negative numbers. And remember, there's a negative in front of the x. This means negative 1. Now, to the power of 2, this means negative, negative x times a second negative x. This means negative 1 times negative 1, which means ultimately positive x to the second. So just x to the second. All right, this next one, negative x to the 3rd, is negative x times negative x times negative x. All right, 2 of them at a time, they will cancel each other out. So a negative times a negative is a positive. That's awkward there, sorry, that's a positive. And then we have this 3rd negative left over. So this is negative. Again, if you want to write 1 and 1 here, and this is negative 1, 1 times 1 is 1, times negative 1 is negative 1x to the 3rd. Or we simply can write it without the 1 and just write negative x to the 3rd. Now, anytime you maybe starting to see patterns, we got negative on the fourth here, negative x times negative x times negative x times negative x. 2 at a time cancel each other out. So the first 2, negative times a negative, makes these positive. Another pair, a negative times a negative, is a positive. So I'm canceling out 2 at a time. They cancel each other out to make positive. So I got positive, 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 positive. So 4 of them. So this is 1x, positive x to the 4th. And you might see we're going even power, odd power, even power, odd power. The next one, negative x to the 5th, negative 1, negative 1, negative 1, negative 1, and negative 1. So we got negative times a negative is a positive, and negative times a negative is a second positive. So we have here negative 1 x to the 5th, or just negative x to the 5th. All right, so as you're seeing, all of these started off with negatives, and then we ended up, when we simplified, some of them have negatives still in them, some of them don't. So when you have negative x to an even exponent, it comes out as positive whatever x is to whatever exponent. So if I had, and pause at any time if I'm going too fast, negative x to the 6 would end up being positive x to the 6 because this is an even exponent. There'd be one pair, two pair, three pairs of negatives that would cancel each other out to be all positive. Then we have negative x to an odd power. This ends up being negative x to whatever power that is. So always looking at if they're even or odd powers. So if I had negative x to the 11th, this would be a negative x to the 11th there. Again, feel free to pause at any time. All right, so just a couple more things. So we did this one, negative x to the 3rd. We had negative x times negative x times negative x. And I'm taking everything with me here. Sorry, get rid of this. Everything with me. And this is 2 at a time cancel out. So you get positives and then in 3rd negative. Negative x to the 3rd. It's just like our rule in front. Now, number 10 is a little more awkward because there's no parentheses. So I have that negative sitting there. And now you just have x to the 3rd power. So we have x times x times x. Okay, so there's only one negative sitting there. There's nothing to cancel out. So it's just negative x to the 3rd. So parentheses are important. If you have parentheses, you take everything, repeat it with it, and repeat it that many times. If you don't have parentheses, that negative just sits there and you're repeating whatever has the exponent, and then the negative just kind of follows along. Okay, negative x to the 0. Well, that means all of this gets a 0 power, so that is automatically just the number 1. So all of it gets a 0 power. Whereas this one, you have negative x to the 0. Just this part has the 0 power. The negative is not included on that. So this means a negative 1. Okay, these are not things you have to memorize, but just knowing how they work and working through those is great. All right, we're not going to work through a rule because we're just going through these and working through them. All right, looking at these, we want to distribute. Go ahead and pause the video if you want to. Distribute that 4 to the inside. So order of operations, simplifying, we do parentheses, nothing to do. Exponents we're working with next. So go ahead and pause if you feel like you're good. And this is going to be x to the 16, y to the 8. So I can drop my parentheses and just say negative 3x 16 y to the 8. We don't distribute to both because there's no plus or minus sign in there. It just is multiply with the 1 here. Number 14 is different because the negative 3 is on the inside now. So, and that has its own power of a 1. So we're going to distribute this 4 to all of this. And I do have to be careful of that negative. All right, so feel free if you're pausing, or feel free to pause if you're good. So we're going to watch this. Negative 3, so this is negative 3 to the power of 4, like this in parentheses. I'm containing it in parentheses still, even though I'm distributing in to contain that negative here. So this would be 81 x 16 y to the 8. Number 15 here. I have 3 m's on top and I have 7, 4, 5, 6, 7 on bottom. 1 for 1 cancel out, so 1 on top, 1 on bottom. 2nd on top, 2nd on bottom. 3rd on top, 3rd on bottom. So I canceled out all my tops, but on the bottom I have m to the 4th. And I need a placeholder That would be a 1. So this is 1 over m to the 4th. Now, if I were subtracting, I would have m to the 3 minus 4, 8, no, sorry, 7, which is negative 4. Anything on the negative, and I'll show you on the next one specifically, will go to the other part of the fraction. And we'll do that on this. X to the 2nd over x to the 8th. So I have x's because they're the same base. I do the top exponent minus the bottom. So this is x to the negative 6th. We don't like leaving negative exponents, so I move it to the other part of the fraction. And right now it's not sitting in 1, so I put it over 1. And I move it down to the bottom. So I've x to the 6th on bottom becomes a positive. And I need a placeholder, so the 1 will sit on top. All right, so lots going on. The 3 and the 6 will simplify. So I have, they simplify to 1 over 2. The x's, I have 5 subtract 3, top minus bottom. And on the y's, I have 2 minus 7. So I have so far 1 over 2. X's, I simplify, I get x to the 2nd. It just will sit there. I got 2 more x's on top. That's fine. Y has a negative 5 with it. So what we don't like to do is leave negative exponents. So I'm going to take this and flip it down to the other part of the fraction. So the 1 will sit there on top. X squared will sit on top. The 2 will be on bottom. And this, to make this positive, y is going to join this on the bottom part of the fraction. So, as a rule, anything with any base with a negative exponent moves to the other part of the fraction to be positive. So anything with a negative exponent moves to the other part of the fraction to become positive. So the exponent. So when I look at this, x to the negative 1, I make it into a fraction, put it over 1, and this is going to move down. So I'm going to have x to the first on top, and I'll put a placeholder, x to the first on bottom with a placeholder on top. So, placeholder m. So I'm going to move this to the bottom part. 5 over, so 5 is going to sit there and not move. X to the 2nd is going to be on bottom. Now in number 3, we have one on the bottom. So it's going to move to the top to be positive. So the 1 is going to sit there. X to the 3rd will join it. Now if you want to make it as a fraction, you can make it 1x to the 3rd over 1, but really they mean the same thing. It's up to you. And then this last one, you see the negative exponent here. You have 3 and x do not have negative exponents, so they sit tight. This whole thing is over 1. So this is what moves, only the 3 and the x sit there. It's not that the whole thing flips. The 3 and the x sit there. And the y to the 4th moves to the bottom. If you want to put a 1 there, you're welcome to. And that's the end of the video. Let me know if you have questions.